Again, there is a bit of latency behind this. So welcome to our viewers on YouTube. I will give a short introduction about today's speakers. So just a second. Yeah, my name is Kurt Willis and I will have the pleasure to moderate today's session. The talk will be live streamed and saved on our YouTube channel. And after the talk, we invite you to ask questions and discuss the topics. This second interactive part will not be recorded and not be streamed to YouTube. So if you're on YouTube and you would like to also ask questions, you can either do it in the chat of the Zoom, the YouTube chat, or you can, for future talks, you can register on the NFDI website and then you will get the Zoom link. So in today's talk, Goedicke, Safial Islam Ayon, Anh Duc Vu, and Lars Meiendresch will present Introduction to Research Data Management Containers. Oh, I see I have a wrong abbreviation. It should be RDMC, right? So today's speakers. Goedicke is Senior Professor of Computer Science at the University of Duisburg-Essen. He specializes in software engineering and specification of software systems. Within the National Research Data Infrastructure landscape, he serves as a spokesperson for the NFDIxCS, a computer science consortium in NFDI, leading the development of standards for research software and data management in computer science. Safial Islam Ayon is Research Associate at University Potsdam with a focus on data infrastructures and metadata interoperability. As a core contributor to NFDI cross computer science, he focuses on the technical implementation of the RDMC framework, ensuring that containerized data meets high standards of findability and accessibility across scientific domains. Anh Duc Vu is expert in cloud computing and container orchestration at the University of Duisburg-Essen. In his role within NFDI cross computer science, he manages the technical integration of RDMC into scalable cloud environments, focusing on the security and high performance execution of research data services. And Lars Florian Meiendresch is a researcher at the University of Duisburg-Essen. He is working on the NFDI cross computer science consortium at the specification of software systems. Working package, I think. His research interests are research data management and software engineering. He's also working at the software of managing RDMCs and supports the operation of the Software Heritage Archive Mirror at the University of Duisburg-Essen. So the floor is yours.
Yeah, thank you very much, Kurt. It's a pleasure for me for us to present our concepts today. We are backing our concepts by first versions of the software, which we would like to demonstrate. We have some videos if the systems don't work as expected, which is a kind of thing which we experience these days quite often. Anyway, also we have a plenary meeting tomorrow and Wednesday as well. So some of our colleagues are traveling and might not be available so directly as we have it from the desktop, either in the office or at home. Anh Duc is traveling and Safial as well. So maybe their presence is be intermittent during the talk, and we will see. So that's that's for the introduction of the presence of the speakers here. I will go through a few slides and explain the concepts at a very high conceptual level, and then go through the go through a demo of the things we have at hand here right now. So the question is, why do we have these concepts at all? Who is using it? Who is performing it? What is actually happening in a research data management container? How we implemented it, and when will it be available? That is, and when it's actually due. I mean, we need research data management for computer science, which it's accepted that it's a very pressing need, and the characteristics of research data management data is actually quite diverse. So it's kind of nutshell of NFDI in a nutshell as well. You have data which is recorded as, for example, you see on the right side, experiments within computer science, for example, HPC heat maps or log files and stuff like that. Software is a broad range of data, partly in unstructured form, partly in very structured form, like abstract syntax trees, for example. We have data which is coming from logic programming, functional programming, theorem proving, which is part of our research data. We have visual data in augmented reality contexts. We have data which is tabular, and we also have diagrammatic data, which is actually models, representing models, abstract views on systems and software and any kind of systems, not only computer science systems, but also socio-technical systems, which are actually quite important here as well. So that's a kind of data we are dealing with, and what we are up to is the findings that no data we have in the long term without the software which has been used to create the data or extract the data from devices, or created the data via simulation, for example. So software is quite an important component in the overall research data management activities at all. I mean, that's not only true for computer science. My thesis is that it's also important for other areas as well. And whoever likes to use our concept is free to come and use it and try it out, and maybe also apply it in their respective environments as well. It's particularly true for data formats which are proprietary. So if you have, for example, data like from the office set or so, or even from the software Unity, which is used in many experiments of HCI groups or other groups in visualization in 3D space, that's actually proprietary data, and you need the software, otherwise you can't access the data here. But also open formats are not easy to deal with. They're of course more open than usual, I would say, in the proprietary format. But these software pieces of data are prone to versions, and if you have it in CSV, you need the specific information, what is actually in the columns in the CSV file, or if you deal with binary data, which is very raw in a sense, you need to have information about the actual representation of the data within those files. And if you want to have very dense formats of data, then raw data in that format is really matters. So it's actually this kind of information which is needed in addition to the raw data, the semantics of the data, so to say, and that comes in within the software which is actually provided in that context, or has to be provided in that context as well. And software is a beast on its own, because it's bound to a specific execution environment. Otherwise, the software in terms of source code is of course very important. But you need all the libraries, you need all the underlying execution engines, be it an x86 or ARM architecture, an operating system, and all these kind of things which are actually needed. So in a nutshell, encapsulation is important because we encapsulate for the long-term archival of research data and research software a container format and additional components as well, which encapsulate all these aspects that you can share your data together with the tools, which are actually quite enables on facilitating the access to the data which is contained there. And then it comes to this kind of picture, because the software is not a couple of lines of code, but you need libraries and all sorts of things which are connected to that. And this is a very famous XKCD cartoon, which says, okay, this little piece down there is quite important because everything on top of it, it's really depending on this little logging software, or maybe monitoring, or something else, or accounting software, authorization software piece. Very little, but essential for running the whole thing. And if that goes away, everything breaks down. So that's a true and very threatening and making you afraid of things which, when you use software at a large scale, and which is the common thing in research software as well. So we are coming up with this container idea, bundling software and data and metadata together. The attempt we have here is fair by design, in the sense that all the metadata will be available openly. We have privacy layers inside to secure not openly shareable data and software. This is due to GDPR reasons, or IDPR, so intellectual property rights, is also important here in some end. And the container is structured in such a way that it provides access control, because we have to provide limited access in certain situations. We provide workflows, how to create. This is due to the GDPR and IDPR aspects. And these are software components around in making the container an object of distribution. And that encapsulates all the things which make up the research data and the research software, which you have been providing here in that sense. So that's the container which will be archived for long-term storage. It's a unit of distribution if you want to give it away to another researcher to reproduce the results, or reuse the software, or reuse the data. And but the container is not runnable in the sense that if you look at Docker, for example, that's the specification of a runnable thing. The container is a time capsule. It shouldn't be changed, because it will be archived and should be not changed once it has been considered to be the deposit of the research data which makes up your results. So that's an important thing. But of course, we will provide means to wake up that data, wake up that software, and make it reusable for other parties in the community as well. So long-term availability, metadata quality, the creation process, and privacy options are the main ingredients in this sense, and provide the pillars of the fair research data management in our context. We create an execution environment to have this all available, and I will briefly show in this exemplary use case how we expect that we use our concepts here. It's a simple artifact submission to a review process, and then afterwards, once the research data has been reviewed, it's available for publication and can be reused afterwards. So submitting an artifact for evaluation goes through a number of steps. You have to include, of course, the artifacts. You have to add the metadata, and then check and choose a license as well. So that's quite important. That's for legal reasons, to protect your ownership and to protect the data within. And then we have to create the reusable execution environment. So that's a measure up front that you have to assemble all the things which are necessary to run the software together with the data, and then sign and seal it. It shouldn't be changed afterwards. Once you have signed it, you can check whether and these kind of tools we provide, you check whether the container has been tampered with. For the publication, you need a persistent identifier, a PID for the DOI or an epic. And then you can submit the RDMC and the reusable execution environment to the review process. So that can be used already by the link we have here. We have all our services in the directory NFDIxCS.org services, and we will go through a demo in a minute. After we have that, then you have created that and put it into the archive, then you can review it. The idea is that the load of reviewing software and data is made very lightly, much more lightly than currently. It's a heavy weight at the moment. You need to download software, you have to install things, and which doesn't work really well. We provide for that reason, that because it's not running very well, to provide a means to run the software in the cloud. So we have an IDE in the cloud, and you can run the software there. If you have, for example, a rebuttal process, the review goes in. Once the review has been done and comes to a conclusion whether the actual data and the software can be published or not, the related result is added as metadata. Again, a signing process or sealing process and/or sealing process is performed, and then it's ready for the publication here in this end. And then it can be reviewed, it can be searched in search portals. You get access. Maybe it's conditional because you need some permission by the authors and owners of the RDMC. And then you can run the RAE. So it makes a conceptual copy of the container and provides all the necessary ingredients to run the software. And then it comes up to then it's open for reuse by the reusing party in that context. So that's a setting, and that's very basic for us. Many more use cases are considered currently, but we will try to get this up and running, and that's enough work to do for us at the moment. That's the architecture. We have our website providing the portal and various services here, like PID registration, the creation workflow, which you will see in a minute, the signing process, and the workflow here again for the RDMC. And then also we have also an artifact evaluation platform, which is a modified and extended version of hot CRP, which is a standard in computer science for doing reviews in settings of conferences and journals. This is part of the overall structure we have in mind. In addition to these workflows and processes, we have also workflows which run for the community, which are supporting decision-making in terms of structuring the metadata, agreeing upon standardized metadata and quality criteria. That's also being implemented currently using a semantic wiki-based approach, which I don't deal with in this talk here. So that's a very coarse-grained picture of the architecture we have in mind. You see here down below DBLP, Software Heritage Foundation, which are kind of also resources we will use in our publication and reusable execution environment creation processes in order to come up with a container. So The demo is now. I try to make a real life demo here, and what you see here is the creation of an RDMC as part of an artifact evaluation process. So the created RDMC goes to registries in terms of that it contains metadata. Currently, of course, we have an own registry to register our data management containers we have in our view, so to say, available. And you can also, of course, get hold of the RDMC by storing it in various repositories like Zenodo, Cosine. Zenodo is working. When Zenodo is working, Cosine is in the development. That's an RWTH-based repository. You can, if you have, we provide the Dataverse and will provide more Dataverses in the future when the DFG storage call goes through finally. But the current Dataverse we have is not accessible because it's under stress at the moment. But you can also download to your local storage and exercise the RDMC on your local resources here. So let's stop sharing the slides here. Let me see and now go through the web browser and give that a chance to be okay. What you see here is our current services. So it comes from, you see here, NFDICrossCS.org/services/RDMC creation workflow. Let's see, So you get here the creation workflow. You get documentation here as well. So read through it. You're invited to read the documentation, of course. You need to log in to the service because it's uploading content to central resources, and we don't want to have anonymized content on our services here in the backend. And so you need to have an academic cloud ID at the moment. We will have, of course, AIM for NFDI services implemented here as well. But academic cloud is a good guess here, and it's part of AIM for NFDI as well. So that's our thing. So you create. I'm creating here a new RDMC creation demo. Oh God. Demo. 2020-04. Let's give it a date. Oops. So as artifact initialization is you give here, I upload a simple file, which is a Python file for demonstration purposes. So this is Python 3 version. It's public. You can have restricted or private here, but we want to be open, so it's public. We upload it from our device. It's a piece of software. We have different. You can have encapsulated RDMC as well. You can create a hierarchy of RDMCs. And now add the resource from my file system. And it's here in the repo. It's main.py, of course, and I validate that. So I have the resource title. It's Python program. It's main Python program. So validate, cause it to upload. It says upload is successful. I hope it can be seen right now here. Okay, yeah, that looks nice. Continue. Okay, the artifact. So there are some general questions and collection of metadata. How does this artifact contribute to research? It's a test. It is a test of Python. Just producing some test output. Here are more specific questions available, which are optional. What hardware is needed? It runs everywhere. It runs everywhere. And so on. We don't have to fill this in right now, but in real life, it would be very important to add here some decent information for describing what kind of software is here in question. This will be amended and extended depending on the various sub-communities and sub-disciplines of computer science by more metadata opportunities for that specific sub-community in computer science. So information retrieval is different from HCI and so on. So that's pressing the OK button then leads to this summary. You can view what's inside here and modify it. You can download it. I save that for here for now. And then you have to create the reusable execution environment. Do it like this. It's so version 4, create. I've prepared this, of course, and now the thing is not working. Yeah, that's too bad. Let's see, does it happen on this? Very good. So I have to give here a repository. Let's see, it should be a zip file. So this one works. Runtime is not relevant at the moment. SBOM also not. The SBOM, I explained it a little bit in a minute. A build script and a validate script. Validation script. Let's see. You see here the info buttons provide a minimal bit of information which is necessary, for example, for the build script. You see here Dockers are built, so the execution environment is created using Docker. And that's one way to implement it, but currently it's the only option we have here. And yeah, you need to create this and export all the necessary bit of information, which is done in the background in the cloud service. You see the status here; it's queued and get here. The log file is very short, running export job, so that's not very much at the moment. But we'll see when the build is. I see you're looking at the watch. We are going to have it done very shortly. So the building of the container takes a little time. It gets, I think, up to 130 megabyte. And you see here also what is happening in the background. It's the log of building a Docker. When you experience with Docker, then you see common patterns here for downloading. And it creates a tarball, and it took 2.4 seconds to do this. Okay, it can also run the validation. That doesn't work at the moment for some reason we don't know. But in real life, that would show you that everything is working well. Continue. You can add here more. So I'm the owner of the thing. You can add more owners. Save it for now. Requires click it away. Select some license, for example, it's GNU stuff, and you can also add some more specific information, for example, computer science and so on. So description keyword need to be Python test, and here I have the test of Python. Save and continue. So then various bits can be downloaded here. It's also compatible to row crate, which is a standard to specify research objects. But the thing on the right side, sign and seal, is more important to our concept right now. So you can, if you accept terms and conditions, it's important to do this. Then you can seal it, and then the container is actually signed with a certificate, and you can check the status of. You can bring it to Zenodo. As I said, Dataverse is not working at the moment, and you can also publish to our registrations. You see Zenodo is opening, and you get. I can try to authorize that. That's an error message which appears in the context of Zenodo. There are some timing issues we don't understand, but that has to do with Zenodo. I can try it again, and yeah, okay, so leave it at the moment, but I promise that works in the end. So the things are in deposit mode. You can deposit your thing in RDMC. Our Dataverse is also working, but the services in Göttingen are currently not publicly available. Once that is done, you can also find the server doing our search services. That will be so. Let's see whether here we have an RDMC. So it's a search thing, and that's. I think that was the thing I just created. So there are some, and what is important, it looks like that. You can here look down what is in there in the thing. You have a handle, and this handle is actually listing the things which are in the RDMC, the status of the RDMC landing page. You see that's pending here, and all sorts of things which are in the metadata, and give access to the research data management. So that's then, and final words have to be shared here as well. I just stop the Freigabe and show you my slides again. So the construction of the reusable execution environment, I have a video as well for that. We support this. This is quite elaborate because software development is quite complex these days. We built in a lot of AI at the moment. The registries are connected to the Open Research Knowledge Graph, DBLP as well. And artifact review is also supported. Oops, sorry. And caution, this is a test, and many more things to come. And thank you very much for your attention. People supported me here, are listed here, and quite a range of other not mentioned here have been contributing to this as well. I would like to thank them, and I'm done with my presentation. Thank you very much, Cord, for your patience.
No patience necessary here on my side. Thank you very much, Michael, for the great introduction on RDMC. So now, before we start the question discussion session, we say goodbye to our viewers on YouTube. The next NFDI talk will take place in 2 weeks on May the 4th. Okay, that's Star Wars Day, obviously. You see. In this talk, Petra Gehring, Deputy Chair of the German Council for Scientific Information Infrastructures, RFII, and Lars Bernard, Speaker of NFDI for Earth and NFDI's Basic Service Initiative Base for NFDI, will give an introduction on Datentreuhandmodelle für die nationale Forschungsdateninfrastruktur. That's data trustee models for NFDI. And this talk will be held in German. So same time in 2 weeks. And I will stop the stream now. Again, this will take